Okay, now that we know what earthquakes are, the next step is to be able to predict them, and that turns out to be very difficult to do. The first step is to know where earthquakes occur. Okay, the second step is to do a survey of that area and find out when have earthquakes occurred in the past. So one way of doing that might be to dig down into the soil in that particular area and look for signs of faulting and then find out when did that faulting occur. So if we dig down into a soil and we find out that an earthquake occurred 200 years ago and then another earthquake occurred 400 years ago, well, then that means that earthquakes in that particular area occurred every 200 years. So that would mean that that particular area is due for another earthquake. So we look at past evidence of earthquakes to predict when an earthquake is going to occur in the future. Okay, then another thing is to look for signs of stress along the zone. So if there's a lot of stress that is, you got a force going this way, and then you got a force going this way, and then the two of them are going to slip. If you can monitor that stress and look for signs of buildup of the stress. So the more stress that's on a fault, the more likely that fault is to slip. You can look for signs of deformation along the fault zone. So signs of where the rocks are bending and they're storing that energy. You're also looking for movement across the fault. So is there any evidence of slippage? And so one way that they do it for the San Andreas fault is that they actually have measuring devices on one side of the fault and another one on the other side, and they're shining laser beams across the fault zone. And then if this laser moves a little bit, then this laser over here won't be able to receive a signal, and then you'll know that the fault has moved a little bit. So they can actually measure the movement of a fault by using this method. Another thing is foreshocks. So this is going to be a series of micro earthquakes that might occur that are signaling that the big one is about to occur. And then there are also some unsubstantiated signs, folklore, that indicates that an earthquake is going to happen. One is water levels in a well. So as the ground begins to crack, then groundwater can start to seep into those cracks, and then that would make the water table start to lower. And so it would make the water in wells start to go down. Another thing is it might, the breaking up of the rock might release radon gas that gets into wells. So that's an unsubstantiated sign. So there are scientists that are investigating this, but there's no conclusive proof that it shows that an earthquake is going to happen. Electrical signals emitted by minerals. So there are certain minerals like quartz that when you squeeze them, they give off electricity. So that if you could monitor the amount of electricity in the ground, maybe that would be telling you that there is forces building up in that area. And then also the reaction of animals. So dogs barking, chickens crowing, and things like that. But again, there's no hard evidence that that actually predicts that an earthquake is going to occur. So how can we reduce the amount of damage caused by an earthquake? So I will talk about that in the next segment.